Excellent. Thank you, Tim. So yes, ECHOiQ is a fully owned subsidiary of Houston we have. So that's ticker HWH on the ASX. So what is ECHOiQ? In simple terms, that we're using the power of artificial intelligence and big data to reinvent cardiac diagnosis. It's basically as simple as that. Can we move through the third slide, please? Who is ECHOiQ? So we're a company with a single vision to use big data and AI to help cardio diagnostics. We're acquired in June 2024 by ASX listed HWH, and basically we acquired a proprietary database and AI algorithms, which we're now building on top of. We have about 387 million shares on issue, market cap of about $62 million, $3.2 million in the bank with another $1.5 million in options coming in over the next couple of months. And our top 20 owns 52% of the company, so we're quite tightly held. And we've got a good, solid backing from our major shareholders. Next slide, please. So we're November the 29th at the AGM, we are rebranding from Houston. We have to ECHOiQ. Our ticker will change to EIQ, and that's based on the commercialization of ECHOiQ and where we want to go as a business going forward. We see it as an awesome opportunity to build a global brand and a global solution in cardio diagnostics. Next slide. So what does ECHOiQ do and what are we focused on? Cardiovascular disease kills 3 in 10 people globally, so that's 30% of the population. We're developing applications that use which use current infrastructure. So we're not trying to change the way things are done. We're using standard processes now, and we're adding to and making it easier for people to clinicians to diagnose what's happening. So the way it works is quite simple. You'll see the picture in the top right-hand corner. You'll see an echocardio machine. It's basically an ultrasound machine. And what that does is it takes measurements of different parts of the heart and also takes images of the heart as well. The first disease that we are targeting is aortic stenosis. Aortic stenosis is heart valve disease. So what happens with aortic stenosis is what the main valve which goes into the heart goes from an average of 3 centimetres down to an average of 1 centimetre. And what happens there is that the heart starts to work a lot harder and the patient ends up having a heart attack. Now, in today's world, they're able to fix that problem a lot easier than what they were able to previously. Previously, you'd need to use open heart surgery to fix the problem. Now, you can go through the groin, put a new valve in the heart, and you can go in on a Monday or a Tuesday, and by Thursday or Friday, you're actually feeling a lot better. You're at home and the problem's fixed. Next slide, please. So the main issue has been around actually diagnosing the problem. And what's happened previously is that there's a lot of patients are missed. So they're saying that there's about 30% of people within guidelines are not diagnosed. And this is happening because doctors and clinicians are rushed. They're not able to spend the time and the effort that they need to work out exactly what's wrong with a lot of their patients. So we're saying that with our AI and with our machine learning that we can help them diagnose and find a lot more patients a lot more effectively and a lot more quickly. And the way we're doing that is we have access to the world's largest database of echocardiograms. So NEDA is a company which was set up about 8 years ago, the National Echo Database of Australia, and that has about 2 million echocardiograms with about 200 million data points. And what we're doing is we're using AI algorithms to be able to write an algorithm which helps diagnose different heart diseases, and aortic stenosis is one of those, more accurately than what you're able to, what are the humans actually able to do. Next slide, please. So the ECHOiQ database, which we have access to through NEDA, we've got a 17-year exclusive access to that. And what that allows us to do is access the data through the echocardiograms of about 1 million Australians. So it's 1 million Australians, 1.8 million echoes, and we're able to use that data to write our algorithm. We've just signed up a second agreement to access NEDA 3, and what that's allowed us to do is have a look at additional health records of those million patients to once again help find structural heart disease and heart failure. Next slide, please. So basically, how does ECHOiQ work? So we have a machine learning and AI algorithm which we run across the data points of the echocardiograms to help find more patients. So currently, we believe that within guidelines, we can increase the amount of people that are found with these heart issues by 50%. And outside guidelines, we think we can increase that by an additional 50% on top of that. Next slide. So typically when you're looking at clinical studies, and we've actually just signed up an agreement with Edwards Lifesciences, which is a $75 billion NASDAQ listed company. Now they're the largest supplier globally of heart valves. Now their current turnover for heart valves is about $4 billion a year, and 3.8 of that is in valve for aortic stenosis. Now, their internal figures are that they leave about 80% of people untreated. So in other words, clinicians globally are finding about 20% of the patients that are actually able to be treated. The other 80% are being missed. So they've actually fully funded the clinical trial to test our initial algorithm at St Vincent's Hospital in Sydney and a second hospital to be named shortly, that we can test our algorithm to prove that it works. Now, we're not a standard medtech company. With a typical medtech company, you're out there, you're recruiting patients, you're looking for people who are prepared to take pills and tablets and all those sort of things. We don't need to do any of that. Because we're an algorithm which runs across existing data, we're able to look backwards and we're able to look on existing data which is in the marketplace. So, for example, with our clinical trial in St Vincent, Sydney, we're looking at approximately 20,000 patients. We're going over their records for the last 4 years, and we'll run our algorithm across it, and we will find the patients who have been missed. They'll then come back in, get looked at by the clinicians and the doctors, and then based on that, we'll be able to prove that our algorithm works and it does the job that we say it does. Now, with a clinical trial, there's actually typically 4 stages. We're currently at stage 3. So stage 1, we've developed the actual algorithm. That's already done. Number 2, we've actually validated the study against an additional 330,000 records. So that's completed, that's published, that's global, that's out there in the marketplace now. So what we're now doing is a retrospective observation and a clinical study. So we're now going to get the doctors at St Vincent's Hospital in Sydney will actually do the tests and come back and say, these are the people that need to be looked at, these are the people who have been missed, these are the people who need to either have a valve or get some additional treatment. Next slide. So then the simple answer is, how do we commercialize this? Where does it make money? Who pays for it? Where do we go from there? And in our opinion, there's 3 solid answers to that, and there's 3 opportunities for us to get revenue. Now, the first opportunity is what I just mentioned with the clinical trial, and that's a retrospective view. So with the retrospective view, we can go to doctors, clinics, and clinicians globally, and we can go to them and say, you've got 10, 20, 30, 40,000, 50,000 records which you have for the last 3 or 4 years. We can run our algorithm across them, and we'll show you patients who you need to bring back in and need treatment. They've been missed. They've been underdiagnosed. As I mentioned before, Edwards, $74 billion NASDAQ listed company, believes 80% of people with severe aortic stenosis are simply not diagnosed. They're missed for whatever reason, or if they're found, they're too old to be treated. So we see a massive opportunity working closely with the likes of Edwards or potentially Medtronics or one of the major valve performers to actually go out there and find them additional patients. Now, a valve will cost between $8,000 and $20,000, so there's a fairly large incentive financially for the valve makers to want to find those people who aren't helped. There's also a lot of pressure on the hospital system, where somebody who hasn't had a new valve placed then has a lot more hospitalizations and a lot more cost based on the hospital system because they're not healthy. Where if they had a new valve, they would be a lot more healthy. The second opportunity is, and we've announced another agreement with this as well, is actually in the workflow, so integrating with the actual reports that the cardiologists see. So once you actually get the echo done, the echocardiogram done, the report and the images get sent to your cardiologist. Now, the cardiologist is looking at a report. We're working with Fujifilm Australia at the moment to actually get a button put on the report. That button will be the ECHOiQ AI button. And what happens is you click that button and that will analyze the echocardiogram, which has just been done with the patient, and it will give you a risk profile based on the numbers and based on our AI algorithm. So we're not trying to replace the cardiologist. We're not trying to replace any current medical devices. We slot very nicely within the current workflow to make people better at what they do, which will end up saving lives. We believe that our algorithm doesn't leave anybody behind. If they're within guidelines, we find them, but on top of that, we believe we will find an additional 50 to 100% of additional patients who aren't found. With aortic stenosis, which is the first disease that we're tackling, or we have actually finished the algorithm, and that's what our trial is being done on. Typically speaking, a cardiologist would look at 4 or 5 measurements to determine if someone has aortic stenosis. With our algorithm, for that same disease, we look at over 100 measurements. So the human can't actually diagnose that amount of information, and we obviously can. And that's simply due to the big data and the 200 to 300 million data points that we have access to build and then to grow our algorithm and get it doing what it does. We have 3 PhD data scientists in the team and the team leader who are working on that full time. The final option is actually integrating into and onto the actual machine, so onto the machine which does the cardiogram. And as the scan is being done in real time, we can actually give warnings to the sonographer who's doing the scan to tell them they can keep going with the scan. There's something wrong here, and continue with it. And we can actually give them instruction in real time. We do see that a little bit away. That does need FDA approval. We are working with an FDA consultant now in the States. With the retrospective review, we don't believe we need any FDA approval. With the workflow and being on the reports, we're working through exactly what we can and can't say now. All good.
Thanks, Andrew. Thanks for your time. I apologise for not pronouncing ECHOiQ, but I didn't actually have my glasses on me, so it didn't quite look like that at the time. Can you tell us about the privacy of the data that you have access to? Obviously, there's health benefits in understanding that data for the patient being contacted, but is there any issues in that regard moving forward?
So the data which we're using is all de-identified. So we don't have the identity, nor do we need it. So with the clinical trial, that's being done in a hospital by the clinicians, and that is identified because they're basically running it on their actual patients. But everything, all the data we have now, which we're training the algorithm on, is all de-identified data.
Understood. And is the target market the cardiac specialists, or can the devices kind of be standard equipment at all clinics or ambulances to kind of to speed up the process?
Not really ambulance. Echocardiograms are done in hospitals and in the actual clinics. So the target market is actually the clinics and the hospitals which have echocardiogram machines. There's about 80 million scans done per year globally. So it's a massive market with the opportunity there is huge.
And can you put a dollar on them on what you're selling, a dollar value and the business model behind that and the size of the market?
We've had the business for 4 months. We've made massive, inroads in the 4 or 5 months we've had it. We are working on that pretty hard at the moment. What we're basically seeing is that our first go-to-market product will be around the workflows and actually getting on the echocardiogram reports. When you have a look at doing that, echocardiogram in the States costs about $2,000. Now, if we're sitting on the report, we think the cardiologist is going to a certain extent, have a duty of care, where they're going, we can do it a lot better than them and we can assist them, then they're going to need to click the button. So they're all paying for reporting software now. So we see our model as a SaaS model, so software as a service where it's a user pay. So if a clinic does 5,000 echocardiograms a year, we would look at potentially charging them $1 per time we run the algorithm. And the next year they do 6,000, they pay $6,000. I mean, mind you, some hospitals do 50 and 100,000. So if you look at the numbers there and see that there's 80 million done a year, and we're charging $1 per person to run our algorithm to better diagnose them, as explained before, the uplift is substantial. And also when you look at that, the uplift is substantial, but so is the actual revenue. So doctors and hospitals, I know we all like to think they're there to obviously help us, which they do, but they're also there to make money. So the more patients they make, the more patients, the more revenue, the more income they get. So we're seeing, $1 a click, you can do 20 million a year if you get some of the market. It's a global solution. There's no country which doesn't need it or can't use it. And in fact, the countries which, like in Europe, like Spain, Italy, where they don't quite have the same quality of cardiologists, would be more likely to use it. So I suppose in a nutshell, we're trying to give every cardiologist the ability to do what probably 1% of cardiologists globally can actually do. And that's diagnose people a lot better, quicker, and more efficient.